an example of a proportion hypothesis test, so a z-test, and we will be using the critical value method to solve this. Okay, let's go ahead and get started. So this problem is about a medical researcher and the percentage of people who think children should be vaccinated. So a medical researcher says that less than 75% of adults in a country think that children should be required to be vaccinated. In a random sample of 400 adults, 72% think that healthy children should be required to be vaccinated. So we have two percentages mentioned, so we're going to have to be careful which one is the sample percentage and the population percentage. And then our step one of hypothesis tests, we will have to determine the null and alternative hypotheses. So let's start by gathering the information from the problem. So the sample percentage mentioned, p hat, the 75 or the 72, this sentence says in a random sample, 72% think, so this is coming from the sample. So the sample percentage p hat is 0.72. So the population percentage mentioned here, the medical researcher is guessing that the real population percentage is less than 75%. The size of that sample was 400 adults, and the significance level we will be using is 1% for this problem. Okay, let's determine the null and alternative hypotheses. This is a proportion, so we're working with p. We have a statement here regarding one of the hypotheses, less than 75%. So less than 75% is going to be a p. So is this a null or alternative hypothesis? The null hypothesis should contain an equal sign, an equality, and this does not, so this is the alternative. Right. Once we have one hypothesis, the other is the direct complement to that. So less than 75%, the complement is being greater than or equal to 75%. And again, the null has the equality and the alternative does not. All right, lastly, let's determine the claim. So finishing up step one, after we find the hypotheses, we should determine the claim here. So the researcher is the one making the claim this time, and the researcher is claiming the less than 75%, which is the alternative hypothesis. Right, so that option sounds like this choice here, less than 75. This is a percent, so it's going to want this as a whole number. It does say type an integer, which is a whole number. All right, looks good, and let's find the hypotheses now. So we want a greater than or equal to on the null and a less than on the alternative, which is this choice here. And this is comparing the population percentage, 75%. Right, let's calculate, let's go and do steps 2 and 3. Let's calculate the test statistic. So our z test statistic is going to be, we take the sample percentage, 0.72, and subtract the population percentage, 0.75. Divide by, and the square root of the PQ over N, we need to make sure to use the P from the population percentage. So square root of P is 0.75. Q will be 1 minus that. We can do that as, that will be 0.25. divide that all by the sample size of 400, and that is what is in the denominator. Right, so our critical value and z-scores might be around 2 or 3 decimal places. Let's find the critical value also now. So we do need to determine what type of test this is. Is this a left, right, or two-tailed test? It's not a two-tailed test since it's not a not equal to. This is one of the one-tailed tests. P less than, so we're talking about stuff that is on the negative side, and that is a right-tailed, a left-tailed test. We can verify that with checking the value of the test statistic. We should usually get a negative test statistic if we are testing a left-tailed test. Okay, let's go and find the critical value. So we're going to want to take the negative critical value. So when we get one, we do want it to leave it as negative. Our alpha for this problem is 1%. So that tail on the left-hand side, we want to put 1% in. So critical value is an inverse, and we want to put 1% in that left tail. The mean for the standard normal is 0 and 1 for the standard deviation. So this will be our critical value. This is going to want 2 decimal places. So negative 2.33 is our critical value. The rejection region for left-tailed tests is less than that negative. So less z-scores less than that negative 2.33. We calculated our test statistic also. This wants 2 decimal places, so this will be negative 1.39 when we round. Right, and then our main decision here. So our rejection region was values less than the negative 2.33. Our z-score of negative 1.39 was not less than that. This is closer to 0 than the negative 2.33. So we are going to fail to reject the null hypothesis since the critical value let's say since the test statistic was not in the rejection region. We would need it to have been a number less than a negative 2.33 to reject. So we are going to fail to reject the null hypothesis, and then now we need to go back and determine the claim. So every hypothesis test begins with assuming the null is right and deciding if we think that that is an incorrect assumption. We have not decided to reject, so we are continuing to assume that assumption, but that does also not mean we prove it correct. The claim was the alternative. So if we had rejected, we would have been able to support the claim. We would be thinking that the population percentage is less than 75%. But we did not reject, and so we are not able to end up supporting that claim. So there is not enough evidence to support. If the alternative is the claim, you want to always word that as support. And if you fail to reject, you always do not have enough evidence to do that. All right, so we can take the notes here. There is not enough evidence to support the claim. So what does that mean? That means that the medical researcher, we cannot agree that they are correct. Let's check that. All right, looks good.